Like all other crops, a substantial amount of fertilizer nitrogen is required to get the optimum yield and quality of potato tubers and to tolerate diseases as well. Potato requires comparatively less nitrogen during the early part of the growing season, that is sprout development and vegetative growth stages, compared to the later part, which are tuber bulking and tuber initiation stages. Excessive nitrogen application during the early part of the growing season leads to delay onset of the tuber initiation stage and decrease the yield. Potato requires an adequate and steady supply of nitrogen from tuber formation to bulking. Therefore, potato growers apply approximately 25 to 50% of total recommended nitrogen at the beginning of the growing season, and the remainder is applied at the tuber initiation stage. Although this scheduling improves the yield and quality of the tuber, it is costly and labor intensive. Controlled release nitrogen, also known as polymer coated urea and environmentally smart nitrogen (OESN), is a cost effective nitrogen application source. A micro-thin polymer coated facilitates the release of nitrogen at a controlled rate and minimizes nitrogen losses from the soil. The rate of nitrogen release from ESN is controlled by soil temperature and soil water content. When water is applied to the soil by supplementary irrigation or rainfall, it enters into the polymer coated fertilizer granule and dissolves the nitrogen into soluble form within the granule. As temperature increases, this nitrogen solution moves out through the polymer coated fertilizer granule into the soil solution in the plant available form. About 80% of the nitrogen is released from ESN urea between 40 and 90 days after application. This period spans over the beginning of tuber initiation stage to the mid of tuber bulking stage. In addition to nitrogenous fertilizers, irrigation management also play a significant role in improving the crop yield. Potato tubers are very sensitive to water stress. Yield may be significantly reduced by water deficit. On the other hand, excessive water application may result in respiration stress and denitrification. Maximum potato production is achieved when the soil moisture is sustained at an optimum level and nitrogen is frequently available during peak demand period within the potato root zone. In order to achieve high potato yield, both nitrogen and water management should be taken into account. A combination of fertilizer application and irrigation management during the early growth stages of potato affects the tuber yield. Both over and under application of irrigation water and nitrogenous fertilizer affect the nitrogen dynamics within the potato root zone. The highly soluble nitrates will be leached below the root zone due to excessive water application. Intensive over application of fertilizer is one of the main contributors to lower yield and elevated nitrogen concentrations in groundwater. If the excess nitrogen is not utilized by the crop, nitrogen may accumulate within the crop root zone in the form of nitrates, which can leach below with a rainfall or supplemental irrigation event. Nitrate leaching in the soil is influenced by many factors such as irrigation management, nitrogen fertilizer management that include nitrogen rate, application method, and splitting over the period, and soil characteristics. And rainfall patterns. Soil type and soil physical properties also affect nitrate leaching potential. To study the impact of different nitrogen application treatments on nitrate dynamics within the potato root zone in Manitoba's local condition, CMCDC in Carberry is conducting a potato nitrogen management experiment in collaboration with Manitoba Horticulture and Productivity Enhancement Center. The objective of this study is to examine the effects of different nitrogen application rates on nitrogen dynamics within the potato root zone in a loamy sand soil and to analyze the nitrate leaching potential below the root zone. The stage of plant growth and rooting depth were the main factors considered in determining the nitrogen dynamics within the potato root zone. representative soil samples within 1 meter below the ground surface were taken at 0.2 meter intervals to determine the soil nitrate concentration at the beginning of each growth stage. During the 2020 growing season, a significant amount of nitrate leaching was observed in treatments where source of nitrogen application was urea compared to ESN. In the 2021 growing season, we are comparing replicated treatments of ESN applied at 280 pounds per acre, 180 pounds per acre, and no supplemented nitrogen to track nitrogen dynamics within the potato root zone under adequate irrigation application. For the project update and results, please visit mbdiversificationcenters.ca or mbpotatoresearch.ca or follow us on Twitter at Crop Centers for project updates.
Hi everyone, Zack here. I work for MHPEC Inc. and I'm here to tell you a little bit about our potato nitrogen work that we've been coupling and working with Haider Abbas at Manitoba Agriculture. And what we've been working on historically at this site here is we've had crop trials here mostly looking at rates of ESN and urea, and we've observed through 5 years of study in grower fields that nitrogen at row closure, which will be approximately late June, more often early July. But at this key juncture, especially on sandy soils such as this one, it's really easy for people's pre-plant and top dressing nitrogen programs to run deficient before the irrigation and fertigation program really picks up to top up the nitrogen regime. So there can be a window between 2 and 4 weeks where the plants have insufficient nitrogen. And what we've discovered at that time is that if we have even a very short window there may be some impact that's noticeable in the crop canopy, but it's really noticeable when we looked at total yield and when we looked at the tuber size profile, especially our larger 6 to 12 ounce tuber size profile, which affects the bonuses. So here we notice that especially when people are running beneath 120 pounds of nitrogen available in a soil test, that there's this impact on yield and tuber size profile. So to that end, we tried a huge variety of rates of ESN and urea applied both pre-plant, top dress, or one or the other. And what we discovered through 3 years of work is that at least on this particular soil type with this particular amount of irrigation that we're applying generally to this site, that we don't see, that we are repeating the grower phenomenon that we observed where you have those few weeks of nitrogen deficiency at row closure before the fertigation program picks up. So to that end, negative results are not always desirable to report, but it is useful to know that at least with combinations and straight up ESN and urea that we've been having trouble meeting these goals. So to that end, Haider has been looking mostly at the nitrogen root profile dynamics, and he's been able to verify that what we're seeing is these products have been leaching away as far as why they're not available to the plants. And then he will continue to study that further in our attempts to find ways to decrease that leaching, which should improve the variability since that, or the availability, sorry, since that is our main mode of loss. And then what we've begun to do with our own growers in fields is there's a huge variety of products and practices that are being practiced every year in this province. So we've begun to more closely watch and survey what the community has been doing and observing their results, especially when they have more soil types than the light texture that we just have available at this site. And so we've been trying to cross-reference between textures, between farms and practices, what particular methods of application, timings of application, and especially products have they been using, and then the impact on that soil nitrogen availability at row closure. So what you should hopefully see from us from the future is a return to off-site research in the attempt to verify both that we need to have that either 120 or 130 pounds of nitrogen by early July, and couple that with evidence that we have products and practices that can get us over the finish line. We will then need to conclude this research because small plots do not necessarily represent an entire 100-acre growing field, and especially across different soil types. We have to represent and go back to the growers and see these products and practices evaluated on the large scale in order to determine that this is cost effective for the community as a way of increasing available nitrogen while also meeting soil and community health objectives by reducing the amount of nitrogen that we leach into the soil and potentially the groundwater supply. So thank you all for your time, and these results can be found at our website at mbpotatoresearch.ca.